All right. Thanks everyone for coming today to our event. So before I introduce Caitlin and the talk that she's going to present, let me first of all thank our sponsors. So CSL, Zendesk, the WeHi, and Matrici have been our sponsors for a while. We have had our events at Zendesk for over a year, so we're always extremely grateful for them and for CSL as well, because without that, unfortunately, we can't really run events. And now we are extremely happy to have Naos, I think is the right pronunciation. I'm actually French, and that's a French word, so that's making it harder for me, by the way. But yeah, we're extremely grateful for their sponsorship and for having the event here today and last month as well. So we look forward to more events with them. So before we move on, I'd like to mention a few events that are coming up. So this one is actually next week, so that's the Melbourne Data Science Week. So Melbourne Data Science is organizing a few different events, like a whole week of different hackathons and tutorials, etc. I believe those events are not for free, but they might be extremely of interest to you. So you're encouraged to check out the more details on their website. We're definitely supporting them. There's also another conference coming up soon. So this one is 22nd and 23rd of November. I'm going to try to say that. It's called the R Open Sci and Conf. Definitely someone with some sort of IT background who came up with a name. I believe it stands for Open Science in R in Australia. And the Unconf comes for, it's not quite a conference because the program is actually not set yet. So the idea is that they take people into groups based on their interest and their enthusiasm, their skills, and that's what's going to create the program. So they're going to come up with projects that they need to hack and solve. So I think that's going to be pretty interesting, and I think, yeah, this one is free, so you might want to check it out as well. This slide is just a couple of tweets about this event that have already been there. Like this one here, for instance, saying, oh, I'm not good enough to be part of the of this event. But actually, yes, you are. Everybody, like there's no, forget about the imposter syndrome. Everybody's good enough, and if you're interested and enthusiastic, that's already enough anyway. So I would really recommend checking it out. And it's celebration time for us. So you may or may not know, we have over 1,000 members as per, I don't know, last week or something. Yeah. I checked again today, and we have 1,012 now. So it grows pretty quickly. 13?
2013.
13. Woo. Let's check again now. So we started 2 years ago. A few months ago, we noticed that we were getting close to 1,000. And we were really hoping we would reach 1,000 by the end of the year, but we didn't expect it to happen so soon. So extremely happy, very grateful, because obviously without the members, we can't, there's no point running events. So we really appreciate your support, especially when you come for events like this after work and everything. We know it's not always easy. So if you know anyone who could be interested as well, please let them know about the meetup page. And, ta-da. And next month is our 2 years anniversary. So I went onto our meetup and I saw the 18th of October, which is almost the exact date, because our event next month will be on the 17th of October. It was our first event. So Gokne was the organizer. You probably remember this first event. Yeah. And we had a beautiful cake that was made there as well. I do remember the cake. That was at Zendesk already, the first event. Yeah. So please join us next month. There will be an event specifically to celebrate this. We called it How Are You? So it will be an evening where we're going to discuss tips around R programming. There will be lots of discussions and obviously celebration. I am hoping for a cake. I already asked. Maybe some bubbles. I don't know. So the date is locked in now. So 17th of October. We would like to do something a little bit different. So instead of a seminar or a hands-on workshop, for this celebration, we would like to have something like lightning talks. So we would like to hear about your experience with R, whatever it is. So we would like you to tell us about what you do in R in like 5 minutes. There will be a link to submit your talk or something, and let me know.
Yeah. So we will send out the event at the invite tonight and tomorrow. So if you want to share with us whatever that you love with R through an R script, R markdown, a slide, whatever really you feel like, and then send us to us. We will put it all together in the same file, so it will look very nice. This will be what we love about R, and then on the night, we will love if you can present it in 5 minutes.
So we'll make the slides basically for them. They just write a little text on what they use it for, and then we make the slide.
Okay. But the idea is to receive something from everyone.
From a member.
And then, we can do that.
And give them a voice as well to talk about what they do. A lot of people do interesting things, and they would like to have a go, but at the same time they don't feel like standing up for 1 hour, and in front of lots of people. So it's a good little experience. So the link will be available in the next couple of days. And the other thing we're working on is having a panel discussion on not only R, but also public speaking, because that's something that comes up often for us. We know a lot of people do amazing things in R, they just don't feel comfortable with public speaking. So we are trying to put together a panel inviting past speakers and external R ladies, people who use R as well in their work. So as soon as we've got the names lined up, we're going to announce this as well. So that should be a really good event. And finally, we always need your feedback. That really helps us improve our events, to know how you receive what we do, what could be improved, what you would like to see in the future, etc. This one is very, very small. It's only 4 questions. Here's a URL. I don't expect you to remember it. Is that, again, going to be posted as well?
So I've just sent an email to all the members, so you should have received already an email.
Check your inbox. It's already there.
Whenever you have some time.
Should have made a fake on it.
Yeah, should have.
Awesome. Alrighty. So let's get into it. So we are really lucky. We're really lucky today to have Caitlin talking to us about her work using R for some modeling work with the Victorian police. So I'm really excited about this. I have no idea what's coming. Just to give a very brief introduction, Caitlin is a mathematical modeler at Mezzo Research, and she's doing a PhD with Swinburne University on astrophysics. So if you'd like to join me on welcoming her.
Alrighty, thank you so much for the introduction, and thank you for giving me the opportunity to speak here. I'm very happy to be here. This is only my second meetup that I've come along to, so I'm very happy to already be standing up in front of you and telling you about what I do. And basically that is going to be about the work that I do at Mezzo. So this isn't a super technical talk. I'm probably only going to talk for half an hour, so you get to go home early, or hang around and talk to me more, which would be very welcome. And I'll be talking about the work that I do at Mezzo Research, and we basically class that as what's called complex systems modeling. And what I really wanted to sort of highlight in this talk is that there are so many different ways to use R, and you can come up with some really cool stuff when you put lots of simple tools all together. So a little bit more about me. Roxanne already introduced me, so I'm doing a PhD at Swinburne. I'm probably about 6 months off finishing, it's less than that now. So I am writing a lot, it's fun. And basically in my work I use statistics to try and look at how galaxies are distributed on very large scales. That lets us look at the accelerating expansion of the universe and things like that. So you're welcome to ask me more about that if you're interested. And something that was interesting for me is that I only came to work for Mezzo in sort of the last year, and before that I only really programmed in C++ and Python. So I've only really been a sort of mainline R user for the last sort of year now. Which has been really good, but that means that the perspective I'm going to give you is one of somebody who's come from other languages sort of into R. So speaking a little bit more about who I work for, that's Mezzo. We say Mezzo, it's not the soup, but it can't not hear the soup when I say it because I'm Australian. So we're a small company, largely based here in Melbourne. So with us tonight is also Athol, who is our CEO, Simone, our COO, and Anthea, who's just started an internship with us today. So if you're interested in talking to us about what we do, we're here and ready to chat. So we call it complex systems modeling, and what that really means is that we take large systems and try and understand them and sort of combine data science and mathematical modeling to help companies make decisions. And the way that this company got started is that the founders have backgrounds in science and ecological modeling, so partially fisheries research, and fisheries are a great example of complex systems where decisions really matter. So I mean, you have to look at the underlying population of fish, which you can't really see, so you need to build a model for that, and then you need to understand how the samples that you take reflect the underlying population, and if you make certain decision rules, what effect that's going to have. And so what came out of that sort of work is the understanding that you can apply that kind of thinking to all kinds of problems, and that's basically what Misa's business is. So largely we look at resource management projects and sort of help companies make decisions. And like I mentioned, we program primarily in R, so that has been a really interesting experience for me to come and work for this company. So how I got into this was that I wanted to take a break from my PhD, and so I did a 5-month internship position with them, and now I'll be working for them once I finish my PhD, so it went very well for both sides involved. So on to what I'm sort of going to talk about more broadly. I thought I'd sort of go a little backwards, and I'd start by talking about systems first, before I introduce what I mean by complex when I'm talking about systems more generally. And then I'll kind of sum up by talking about it altogether as a whole. And throughout that, I'll highlight the different ways in which we use R and how that's been really interesting. So basically, a system can be defined as a connected series of connected elements that interact together to produce some sort of behavior. So the economy is a system, your body is a system, the climate is a system. And I would definitely say that they're all complex systems, and that means that they have many moving and interacting parts, and just changing one thing might result in behavior that you don't entirely expect. And so these sort of systems can be generally comprised as sort of, many connected feedback loops, and what systems modeling is about is trying to understand not only all of those on their own, but how they fit, play in the bigger picture. So it definitely works really well for sort of nonlinear systems. I would really highly recommend this book. It's called Thinking in Systems by Donella Meadows. It does a much better explanation of what systems are than I could possibly ever do. So if you're interested at all in what systems modeling really is and what it means, I would really highly recommend it. So when we kind of come to applying systems thinking, there's sort of these 3 different processes, and generally they kind of form a circle. So we go from data, we process it, we build algorithms to kind of understand it and implement decisions or choices, and looking at the results from making those choices and influencing the system leads us to decisions, which leads people to collect more data, and the circle continues. And the reason I think that R and sort of RStudio as an IDE provide a really good ecosystem for doing this in is because it gives you a nice way to deal with all 3 of these pieces. So R is well known for being really great at handling data. You can process huge amounts of information, very nicely summarize it, transform it from one form to another, and really take a good look at what you're playing with. So in that way, R's been fantastic for what we do, and I'll talk about that more in a bit. It's also quite a good language for scripting and building functions, so you can do anything from building a very simple script to do a small piece of analysis to building a sort of web of connected functions, and maybe even turn that into a package if you think that that's something that can be reused. I also think it's super nice how well R is available to people, and that people put their packages up online, and everything's available, and chances are if you need to solve a problem, somebody's solved it first. And so having access to all of those tools is a really amazing thing for the work that we do. And then finally, as a whole ecosystem, it's quite straightforward to make informative plots, and that's either for you might be trying to explore your data, in which case doing that directly in our studio is really nice, or you might be exporting that for another person. For in our case, it's usually the client. But it's also great for making reports and all of these other sort of outputs that make it easy to communicate results to other people. And so I'm going to touch on all of these things, basically through the work that we've been doing for Victoria Police. And we've been doing that work for a few years now, and what it basically boils down to is that Victoria Police have two questions they wanted us to help them answer. And that was, how many recruits do they need? Obviously infinity. No, crime in Melbourne's not that bad. I feel bad now. I feel safe here, it's good. But also, where should they put them? So if they ask the government for that many, well, Victoria is a big state with a lot of police stations. So where do they actually put those people in order to have the most impact? And so these are the really broad brush questions, and there's a lot of, if you start thinking about it, there's a huge amount of influencing factors. And so what Mizo's job is to understand all of those influencing factors and really drill down and help them answer these questions. So basically we start with data. We now have over 30 different data sources that comprise about 0.5 gig of data and millions of entries. And so being able to actually process that, use it and understand it is something that's really important. And to kind of give you a sense of where the complexity is starting to come from, that data covers all sorts of different aspects. So there's crime events or 000 calls or event management, so that's when you see the police at the football, or traffic incident reports. And it spans a huge range with varying levels of quality, which is unsurprising. So basically, we have built an R script that reads in all of that data, cleans it the way we need it to be cleaned, formats everything consistently, and then that way we have a data product that we can actually use for the sort of modelling that we do. And basically the key packages that we rely on to do that are largely the tidyverse. I don't know how many people are familiar with the tidyverse. It's amazing. As a person who has come from Python, where the documentation isn't always wonderful, I found the tidyverse packages all incredibly easy to use, easy to learn. Not always intuitive, but definitely, learnable. And so that's a really major aspect of why doing this work in R is so, so easy. We also use the save RDS function for compression. That's really great because we go from, the 0.5 gig of CSVs that they give us down to, a 14 megabyte R object, which makes a big difference for us. So, when we go from, if we were to read in those CSVs every time, that'd take 40 seconds, but loading the R data object takes less than half a second. So that makes it easy for us to, quickly load the data in and start working on it. So to talk a little bit more about algorithms, the actual algorithm that underlines our work is fairly straightforward. Basically, you can kind of think about those questions of how much, how many staff do we need as being linked to demand. So how much demand is there for policing services across the state? So basically what a major achievement for Mizo has been is to take all of that data and build what we call the composite demand index. So using all of those different data types, we've built a picture of what we think demand for service actually looks like across the state. And then it's really just a matter of saying, let's calculate that indicator for many different stations across the state and say, who has the most demand per staff member? What happens if we give them a staff member? Let's recalculate it, and then the next highest gets another staff member. And that's been, it's fairly simple, but it's extremely effective, and it allows us to get at both questions, which is, if they have a set number of recruits, we can tell them where the model recommends they go until the last one, even in what order. Or, if they want to say, well, how many staff would we need to bring it to a certain level of demand, we can do that too. And that, R's quite a reasonable scripting language, so it's really easy to implement that sort of algorithm based on the data that we have. So that process kind of gets repeated as necessary. So that's kind of an introduction to the system as a whole, and kind of what I want to pivot to now is the fact that it's a relatively simple algorithm to kind of deal with the system, but really the complexity for the complex systems modeling actually comes from how we determine that indicator, which is the thing you might have already guessed. And I certainly cannot detail exactly how all of that works, but what I will do is give you two examples to kind of cover the types of thinking that are involved in systems thinking and how we were able to approach this problem and actually build this indicator. So the first one is a sort of scenario that came out of the data. So you have two regions, and here we have region 2, which has a slightly larger station, slightly more people. So let's say that there's an incident in region 1, but unfortunately, they're too busy to attend it. So what happens is that region 2 gets called, they've got some extra capacity, they go and handle it instead. Now, when we look at this, we say, well, who should get the resources? So region 1 should have been able to do the work, but they couldn't, and region 2 came in to help them. And the difficult thing is, and the reason why this is a question, is the fact that the data shows that the work was done by region 2. So if we were to take this indicator and purely map it to the work done, we'd be giving the resources to region 2, who really don't need more. And basically what would be happening is we'd give them resources, region 1 still wouldn't solve their own problems, so region 2 would come in and do the work, and you see this is where the feedback loops come in. And so this is where the systems thinking is incredibly important, because as human beings, we're able to look at that data and actually understand there's a feedback loop there, and we'd like to do something about it so that it doesn't keep persisting. And definitely identifying these feedback loops is pretty much the key to all of this systems modeling. And that just combines, you know, it's sort of a mixture of looking through the data, but also talking with the client and really understanding how they think the system works, and lots of back and forth, which is why I find it extremely rewarding. So to talk about another example, we've got, you know, something that's also important when you come to building sort of indicators for things is picking the right driver, the right cause. So in this example, this is something we also found in the data. Basically, when there's a crime, forensics will attend and collect evidence. But you can imagine over a whole month there are many crimes. And what happens is that there's a prioritization about which crimes forensics will attend based on how many people they have available to do that. You know, they're not an infinite resource, they can't attend everything. And so what happens is that the data shows us which crimes they did attend, not all the possible crimes they could have attended. And so if we were to make demand proportional only to the attendance of those crimes, the groups that have more ability to attend are going to get the resources because they're going to more crimes. And so that's, again, another sort of positive feedback loop. They go to more crimes, they get more resources, they go to more crimes, they get more resources. But it's not a helpful positive feedback loop in this case, because sometimes feedback loops can be positive. Sometimes you would like systems to grow and eventually, you know, taper off. So what we had to do in this scenario is actually cross-reference other data sources within, you know, the data that we had from Victoria Police to say, well, how many crimes could they have possibly attended? You know, what were the crimes within their jurisdiction that needed this sort of service? And so once we use that as our proxy instead, we can see the groups that are underutilized, like that are under-resourced. And they're going to be the ones that we tell the model, hey, you should give people to, you should prioritize these units that don't have enough resources. And so this is one of those cases where we actually had to look at the bigger picture and look for data outside the immediate, you know, data from forensics in order to identify that, you know, feedback loop and address it. And so hopefully with those two examples, I've given you, you know, at least a kind of picture into what the process of work at Meso is like, is that we, you know, collect the data and we try and understand it. and then build the model and the algorithms and the sort of, this composite demand index to reflect what's actually going on in the system. So I want to just, in my last sort of section, talk a little bit about how do we actually communicate all of that stuff to Victoria Police. They're really busy people, and it's very important that we communicate very clearly with them, because over time we've built a very good relationship with them, and they really trust us to deliver them useful information that they can really rely upon. And it's very important that when they stand up and give press conferences, they can really trust the stuff that we've been telling them. So I wanted to just talk a little bit more about the features of R that we actually use to kind of aid that product delivery. So one of the things that I worked on during my internship at Meso was the ability to build an automated report. So this is really great for Victoria Police because, most of their staff work with Word and want to be able to sort of translate the work that we've done to them into their own internal documents. So if we provide it to them in a Word document, it's very easy for them to do that transfer. I personally don't use Word very often, and so when this got tasked to me, I went looking for a way that meant I didn't have to do very much with Word. And something I'm really impressed by R about is the fact that such a thing exists. I didn't know. It's amazing. I would have thought we'd have to write a Word document every year. No, it's brilliant. I can write code in R that translates, that puts all the pictures together and the explanations and the data sources and everything. And then it just goes to a Word document. It's amazing. And so the things that we're using for that, people might be familiar with them, is that we're writing things in R Markdown and then using Knitr to convert that to a document. So part of what I did was that when you're working with docx, you need to provide R Markdown with a sort of template. And over a while, I was able to figure out, interesting things that I could make it do. So not only did I manage to make it do, nicely styled headings, but, I also mapped things like larger spaces or page breaks. I can get it to auto-populate the date inside Word, which is great because it means that when we rerun the report every year, it already has the correct date in it and we don't look very unprofessional when it doesn't. And things like table of contents and all sorts of stuff. So when Knitr is armed with that, it's basically able to go from this sort of, very basic R Markdown structure and produce something that looks really professional for us. And it's really amazing. I've never come across such a powerful tool for this sort of thing. So I was really, really impressed as someone who'd only just started to learn how to use R. So there's the automated reporting, but then there's also what we've been calling the control application. So those scenarios that I talked to you about, something that's important is that Victoria Police should be able to try and change them and see what happens to the allocation. And that's important for us too, because without doing that, we don't know whether we've, changed the feedback loop or not. But we're very comfortable touching the code in RStudio. Victoria Police are very uncomfortable touching the code in RStudio. So even if we were to present them with RStudio and say, you just have to push the run button and change this one line, they really don't want to do it. And we can understand that. That's completely understandable. Until I started programming in, my honours year at uni, I was terrified of code. It's really scary. You think you're going to break the computer. So, it's completely understandable that they really don't want to do that. So what we've been able to do is use Shiny, which probably lots of you are familiar with, to basically turn what for us is a very large script with many different sort of switches for how the different scenarios work into an actual sort of app format with drop-down menus, and that's something that police are much, much more comfortable with. And that's really critical because we want the model to have a use after we stop working on it. We want to be able to give it to them and say, this will work. you just have to put the inputs in, and it will, it will run and it will make these plots that you're used to, and you will be able to keep using this, because I think there can be, issues if you don't consider usability with actually getting people to use the product that you've spent so much time developing. And again, this was a really cool learning experience for me, because I'd never, built an app or anything like that before, and I found it really straightforward to just use the tools that R has available. If anybody wants to know more about Shiny, I did notice there's an R Ladies Git tutorial for it, so you should definitely check that out. So yeah, that's sort of it for how our work goes and the different ways in which we use R. But it's important to acknowledge that we can't make a perfect model. There is no such thing. And so modeling is always an ongoing task for us. And, basically that's because, every year there's more data, or Victoria Police want us to consider some different aspect that we've not considered before. So originally the model was just built to do regional allocations to, police stations, but now it's built to do specialist operations, but also, how their Victorian public servants work, and many, many things. So it keeps growing in that way, and I think that R really supports us to be able to do that. And with tools like R Shiny and the automated reports, we're also always improving how we deliver products to them and trying to increase usability. So we hope that we can take that Shiny app from just the control inputs to actually displaying the different plots and helping them really see and play with the models, so that they feel like they're in control, and they feel like when they test these scenarios, they really know and understand what it is that they're doing, and they can use that to make really, really critical and important decisions. So even though there's no specific tool for complex modeling, R's such a great environment to do this in, because it lets you do the data, the algorithms, and the decisions all in one very nice space. I've also been really impressed at how nicely R packages play together, particularly, the tidyverse offers you so much of the functionality that you actually need to do most of the work that we do. And, it integrates so nicely that it's very easy to quickly get insights from the data that you have. And it really is a testament to what a great language it is that, we've been able to build this system that Victoria Police are really keen to use and really want to use every year. So thank you for listening to me speak about how we use R at Miso. I'm happy to take any questions.